Okay, so today we're going to learn about creating exponential equations giving word problems. Exponential equations is probably one of the more applicable to real life ideas in math that we have in our class. There are lots of different examples of exponential equations out there. Specifically, our COVID-19, that graph of all of our new cases and things is an exponential graph. So there are lots and lots of different applications that we can do with it. So our equation, y equals a times b to the x, that's just our generic exponential function equation, where b is going to be our growth rate. Now, in order for it to be a growth model, b has to be bigger than 1. So when we are given a percentage of increase or decrease, or a percentage of increase rather, we're going to do 1 plus whatever that rate is of increase. In order to do a decay model, our decay model, b is going to actually be in between 0 and 1, so or less than 1, kind of like 0.5 or 1/2 or a third or whatever it is. So in this case, we're going to take whatever our percentage of decrease and we're going to subtract it from 1. So we're going to do 1 minus that rate. A is always going to be your starting point or your initial value. Oops, my handwriting is really horrible today. I apologize. R is your percent of increase or decrease. And X is typically your time in years. We might have a couple questions where it's not quite years, but it's okay. For the most part, X is your time in years. So some words that we might come across for growth, we might be talking about a percentage of increase, or anything growing, or maybe doubling. Any words that would make it sound like you're going up. Decay, you might be given a percentage of decrease. You might talk about depreciation, especially when it comes to the value of cars after they've been sold and you drive it off the lot and it depreciates. Your half-lives from science are going to be a decay model. Now, there are probably other words that we'll come across, but those are just some of the biggies. And for the most part, anything that would mean decrease is a decay. Anything that means increase would be a growth. Alrighty, let's look at a couple examples. Alrighty, so 1990, Florida's population was 13 million, and the population was increasing at a rate of 1.7% each year. So write the function that represents Florida's population growth since 1990. So if you look at our words, first we need to figure out if it's growth or decay. Since we're actually told it's a population growth, we know that it's a growth model. We are starting off with 13 million. Alrighty, now we were increasing at a rate of 1.7% every year. What I like to do, I like to change my percentage to a decimal first and then add 1 to it. So in order to figure out our growth factor, we have to do this 1 plus, but we need to change 1.7% to a decimal. So 1.7% means per 100, so I just need to divide this by 100. A shortcut way to do that is just to take your decimal place and scooch it over 2 decimal places, and then wherever you have a little empty bump becomes a 0, and my decimal is right there. So I want to add 1 plus 0.017 together to get my growth factor. So it's going to be 1.017. And X is going to be our years since 1990. Usually with years, you're going to be given a starting point. So if you wanted to figure out what your population would be in 1995, you'd want to just use X equals 5 since it's 5 years since 1990. So my equation is going to be Y equals, my initial value is 13. Just remember when we're talking about this, it's in millions of people. My growth rate is 1.017, and we're going to raise that to the x, and then we're done. Alrighty, example 2. So, since 1980, the number of gallons of milk a person has drank has decreased each year by 4.1%. In 1980, each person drank 16 gallons of whole milk a year. Write an equation to model the gallons amount of whole milk drunk per person. So, since it has decreased, we know that this is going to be a decay model. So my starting amount, we know that we start off with 16.5 gallons per person. My growth factor, I want to do, since it's a decay, I'm going to do a 1 minus 4.1. When I divide that by 100, I do 1, 2. So it's going to be 0.041. Now, I don't expect you to know exactly what 1 minus 0.041 is. We're going to pop that into the calculator. So 1 minus 0.041 gives me 0.959 is my growth factor. X is going to be our years since 1980. So now I just need to kind of put all my parts together. So my equation is going to be y equals, we're starting with 16.5 gallons. We're multiplying it by our growth rate, or growth factor rather, and then we're raising it to the x. Okie dokie. Couple more examples here. Example 3, 1998, Clayton had a population of about 13,000 people. The population is increasing at a rate of 1.4% per year. So we're starting with 13,000 people. We're told we're increasing at that rate. Because we are increasing, this is going to be a growth model. Our starting amount is 13,000. Now, since we're increasing, we're going to do 1 plus 1.4. If I go 1, 2, and then put in a 0 and a decimal, that's going to be 0.014. I want to add to it. So 1 point. I can go ahead and add 1 to decimals pretty easily. You just write 1 point and then the decimal. It's the subtracting that I don't always like to do. Alrighty, and then this is going to be years since 1998. And my equation is y equals my starting amount of people times my growth factor, raise it to the x power. Alrighty, last equation. We're buying a used car for $18,000. And it loses 12% of its value each year due to depreciation. So find the value of the cars after 5 years. So first thing we need to do is come up with our equation. So we know that it's starting off at $18,000 and it loses 12% of its value every year. So in order to, so I'm going to have to do y equals, my starting point is, or my initial value is 18,000. I'm going to need to do a 1 minus 12%, if I scooch it over 2 decimal places, is a 0.12, and then raise it to the x. You can definitely leave it like this, or if you want to simplify that 1 minus 0.12, you can do that as well. I'm going to go ahead and simplify it, and that gives me 0.88, and then raise it to the x. So if we're losing 12% of it, we're keeping 88% of the value. If you kind of think of it as starting off as 100%, 100 minus 12 is 88, and then just make sure, though, for our rate that it is a decimal. Alrighty, so after 5 years, so x is going to be equal to 5. So I'm just going to substitute in 5 in for x, and then I can just pop this into the calculator exactly as I see it. So here we go to kind of show you how to put things into the calculator a little bit. So we have 18,000 and then do 0.88. And then you want to use the little caret symbol here to create to put it up into your exponent. And we want to know about 5 years. So I'm going to put that as a 5. When I hit enter, I get 9,499.174. I'm going to round that to 0.17 since we're dealing with money. So y equals $9,499.17. So the value after 5 years is $9,499.17. Alrighty, so I'm going to be uploading the blank copy of these notes so that if you want to, you are more than welcome to fill them in as we go along. And if you didn't, that's okay. You don't have to. I will have a Google form up for some practice. We'll do a little bit of practice with this for a couple days. And then for most part, you guys are done with your Algebra 1B class. Congratulations, and I will hopefully see you guys soon. Bye.